All right, we're now going to shift over to the server side of things. We spent 9 weeks talking about the client, and we studied different things that go on the client side. And those included plain old JavaScript, Bootstrap, which is sort of an augmented CSS or a framework to use for CSS. That occurs on the client, the CSS things. We talked about jQuery a bit, and we talked about jQuery UI. All these things happen on the client side. And what we mean by that is they all happen after the web page gets delivered to the client. So clients make requests through the internet to a server. The server responds with a web page. That web page consists of HTML, JavaScript, and CSS. Now, included in that could be Bootstrap and jQuery. Those are really just things built upon JavaScript and CSS. So that's what gets returned back, and these languages work on the web page that has been delivered. So there's a request and a response. And for plain old static web pages, all the server does is it finds the HTML page along with the other things and delivers it to the client. We're now going to get into server-side scripting, which is going to involve not having completed web pages on the client, on the server side, but having scripts. What do I mean by scripts? Scripts are programs. All right? I mean, there's probably a subtle difference between a script and a program, but it's not really worth splitting hairs. They're programs. They run on the server. The server understands these server-side languages, and they are used to actually write the web pages. What these scripts typically are a mix of HTML and some server-side language. What are examples? Well, we're going to cover PHP in this class. But there's other languages, there's many other languages. There is Ruby, there's Python, there is ASP.NET with C#, there is a number of Java-based solutions. So there could be any number of languages on the server side, but they all do the same thing. They run on the server and dynamically create the web pages. If a client were to look at this, or if you were to look at this, you would not see a completed web page. You would see a recipe for a web page. You would see the instructions to create a web page. And it would partly be HTML, and it would partly be one of these other server-side languages, in our case, PHP. So the server has a bigger job in this case, because the server takes those instructions, those scripts, executes them, and outputs, guess what? An HTML page. In any case, regardless of whether it's a static web page or a dynamic page, client gets back a web page that consists of HTML, JavaScript, CSS, and some other stuff. The only difference is in the case of a static page, the web page is complete and the server does not have to process it. All right. And in the case of server-side scripts, it's a recipe for creating a web page. It's instructions to create a web page that the user or that the server processes, and the output of which is the HTML page that the server is going to use. Okay, so when we're only using these static pages, we can just double click on the web page and it'll open up in the browser, because the server really doesn't have to do anything to process a plain old static HTML page. But we can't do that anymore now that we're in PHP land. We're dealing with server-side script, and therefore we need a web server to do it. Now, I have a web server installed in this machine, and we'll look at some aspects of it in a bit. But if you do not have a web server installed on your machine, which you probably do not, the one that I recommend you getting is XAMPP. This is cross-platform. It exists for Windows, Linux, OS X. It will include a bunch of stuff. It will include, we can see, pick this, it will include an Apache web server, PHP, PHP admin, control panel, and other stuff. I have a video about installing this. Or actually, I posted a video about installing this. Actually, I am incorrect. This is one about PHP. I think it includes some XAMPP stuff as well. I think I've also created a video. There we go. That you can watch. It talks about installing XAMPP. You should make sure that you do this. All right, you should make sure that you've installed XAMPP as soon as possible, because you need to be able to use a web server to do anything in PHP. So whether you're talking about viewing the examples or trying to do any of the homework assignments, you need a web server installed. So if you don't have a web server, which you probably don't, you need to install XAMPP. If you have any trouble at all with that, please let me know. I then have some other things, some examples, some videos that I have linked here, and what things to do this week, so on. In addition, I have the W3 schools parts of their PHP tutorial. Remember, this is a blended class, which means you get one lecture a week and the rest of the time is meant to be spent online. That doesn't mean that it is spent without me, all right? I am still there, even though the course material is online. So if you have any questions at all and you can't get things going and you can't get XAMPP installed and so on, well, then contact me. Well, how do you know if XAMPP is installed correctly on your machine and you have it up and running? I don't have XAMPP, but I have another web server. If you type in localhost, that's the name of your local web server, you should get something. In my case, I have Microsoft IIS installed, so I don't get the same thing that you will get if you run XAMPP. But you shouldn't get something like, can't find this address, can't find this page, whatever. You should get a meaningful page. The other thing to do is try to run my examples. We're going to go over a couple of examples today, or rather a couple of variations of the same example today, and look to see if you're able to run these examples. All right, Now, for these examples to work, if you download these examples, which I've already done, so I won't do it again. You have to put these examples in a special place. So I copy these examples that I've downloaded, and on my machine, running the Microsoft server, the default location to put these is CINET-pub www root. You will have your own special directory that you need to access, and you need to put the files there. But they can't be just anywhere. Okay, they can't be just anywhere on your machine. They have to be in what's called the web server's root directory. And again, if you have trouble finding this, let me know. This is a small class. I can afford to give you individual attention if you need it. So that's not always the case in many larger classes. So please take advantage of that and don't struggle on your own for too long before you seek assistance. So copy it into the special place. I can then access it by typing in localhost / and then the name of the file, in this case, first.php. I can't simply double click on it. If I double click on it, it doesn't know what to do with it, because this needs to be processed for a web server in order to produce meaningful results. Just double clicking it will try to open up the file like you're opening up a Word file or something, just opening up the file directly. And that doesn't work for PHP. You have to have it so that a server processes it and displays the results. This effectively is like looking at a recipe. You'll not see a completed HTML page. You'll see a recipe or instructions. All right, so let's preview what this does. All right. First page we're going to look at is called first.php. It's in my web server's root directory. And it's called first.php. Therefore, to execute it, you don't type in the browser CINET-pub www root. You type in localhost / first.php. And if everything's been installed correctly, and if you have the file in the right place, you'll get this result. This page was made via PHP, and all this is a table of a number and the number squared from 1 to 100. It's a simple, basic HTML page. If we view the source of this HTML page, we're not going to see PHP code. We're going to see what got delivered to the client. Remember, when we're in the browser, we are the client when we're requesting this web page. So we'll see not the PHP script, which is in server land, but we will see the output of that script, which is the HTML. So if we view the source, we're going to see the HTML that got produced. Here we got an H1 that says this page was made via PHP. We have a table. Notice that this table is, the code isn't formatted, and that's often the case with server-side code because you can output the HTML any different way. It's not like when you're writing it by hand and you're trying to get it to be exactly formatted very neatly. But you see, we have this gigantic table tag, and we have the end body and then HTML. So let's look at the source code, all right? This is the output of PHP. It is the HTML page that the PHP produces. Let's look at the code. that produced it. One quirk about the way my web server works is I can't edit this. Where? Yes, I can. I'm sorry, I stand corrected. I'm going to edit this in Visual Studio Code. They give me grief when I try to save it. All right, let's look at the code here. You'll see a mix of basic HTML and PHP code. If it's plain HTML, it simply gets sent to the client as is. So the doc type, that's plain old HTML. The HTML tag, the head tag, the title tag, all these up to line 10, excuse me, all these up to line 10 are just plain old HTML. So they get sent to the client without any processing at all. The PHP code happens starting at line 10 and goes from line 10 to line 18. And let's look at that a little more closely. First of all, we have this PHP declaration. I don't know what the technical term for it is. That says the following code is not HTML, but is PHP. So your web server better be able to understand PHP for this to work. If you download XAMPP, you should be okay. This indicates the end of the PHP block. So these two things go together. Here's the start of PHP land. Here's the end of PHP land. Everything between those things, those items, are PHP code. Everything before and after is plain old HTML. Now, first thing I have is the word print. What does print mean in this context? It means send to the client, send to the browser. So these lines were sent to the browser because they're plain old HTML. They don't need processed. What was sent to the browser here? A table tag. See, we're writing HTML. We're sending the tags necessary to do a particular job. In this case, we're sending a table tag. When the browser gets that, because of the way it's written, it will interpret that as a table tag. It will make a table. So far, so good. Next line, we are outputting top row, the headings. Number and squared. And we do that simply with a print statement. Print. A TR tag, a TH tag, the word number, an NTH tag, another NTH tag, or another star TH tag, the word squared, an NTH tag, and the NTR tag. So we're outputting a single row to the browser. When you see print, that's what that means. It means send to the browser. Stuff that's not PHP, stuff that is in HTML land, gets sent to the browser automatically. If you're within a PHP block, the only things that get sent to the browser are the things that we include in a print statement. In addition, We could also change this to echo. And it would work the same way. So print or echo mean the same thing. Now, notice that this is enclosed in quotes. These are enclosed in double quotes, and that's if you want to send a hard-coded string. In other words, I always want to send these tags and this text exactly as it is. I always want to send that to the client. We're going to skip this for a minute. Finally, we send the end table tag when we're all done. So we send a start tag, we send the header row, we do this stuff, and then we send the end table tag. Now, this is the stuff that is maybe a little more interesting. Think if you had to do this by hand. If you had to create this page by hand and all you could use was static HTML, well, this would be a little tedious to manually create, right? Because you'd have to hand code 100 table rows. What's more, you'd have to know the math. I mean, I could probably get squares up to, I don't know, maybe 16. I could probably tell you the number squared. Once you get past 16, well, I might be able to get some of them quickly. Other ones I would have to, count on my fingers or something. All right. Here we're letting the web server do the math. So we have a for statement here. For statement here works like the for statement works in other programming languages. We set up an initial starting value for some variable. If you notice, this variable starts with the $sign. Variables in PHP start with the $sign. $n is the variable named n. So we set n initially equal to 1. The middle portion is how long we repeat this loop. We repeat this loop until n is not less than or equal to 100. In other words, to say this is we will repeat it as long as n is less than or equal to 100, or we are going to stop when n is greater than 100. And each time through the loop, we increment n by 1. So the first time through the loop, n is going to be equal to 1. The second time through the loop, n is going to be equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up through 98, 99, 100. At that point, we're going to increment n one more time, and n will have the value of 101. All right. And then we will drop out of the loop because n is no longer less than or equal to 100. So really, if you've done any other programming at all that had for statements in it, it's the same format. The only thing that looks a little bit different about this is the fact that the variables begin with a $sign. We then enclose in these braces, we enclose the statements that we want to do each time through the loop. That's why the end table tag is after this brace, right? Because we don't have an end table tag after every row. We only have a single end table tag after you're completely done creating the table. So, first time through, n is equal to 1. I say n times n. That's also 1. and I assign that to variable $S. Notice here we don't have to declare the variables. We don't have to say what type they are. PHP figures out what type they are based on the value and how we're trying to use it. That is both a blessing and a curse. I mean, it's kind of neat, it's kind of convenient, saves you a little bit of typing, but sometimes if you treat a value a certain way and that value in that variable isn't that way, like for example, you try to put a string and treat it like a number, PHP will attempt it, but will blow up and give you an error. All right? So what we've done here is we now have $S is equal to 1. We then print out a TR tag, so a table row, that contains 2 TDs. One for the number, which is $N, and one for the number squared, which is $S. Notice how we don't have to concatenate things. We just put the variable smack dab in the middle of this string expression. These double quotes are sometimes called magic quotes because they're smart enough to know when you're using a variable. And you don't literally want the word $N to be printed in the table. You want the value of the variable $N. So therefore, that's what it's going to output. The value of $N, the value of $S. We close the loop, and then we continue with the loop to the next value. So N equals 2. We square 2 and get 4. We output that. So by the time we're done, we have this. It's a simple example, but it does illustrate the value of using server-side code. It eliminates us from a repetitive and, I won't say complicated, but an involved task of squaring all the numbers from 1 to 100. Now, if this was only 1 through 10, it gives me the numbers only 1 through 10. Now, what happens if we make a mistake? And what are some of the common mistakes that we might make? All right. One mistake that we might make is we might forget that there's $signs in front of the variables. We get this error message that says the page isn't working. All right. Not a very elegant error message. All right. It simply says that the page isn't working, and it gives us the HTTP code of 500, which if we look that up, simply means the server encountered an unexpected condition. Now that's not very meaningful to see this error. All right. By default, PHP suppresses error messages. Why does it suppress error messages? Well, it suppresses error messages because in some cases, the error messages which are delivered by PHP could be used by people that are trying to infiltrate a system. So therefore, the idea is by default, we're going to make it not display any error messages. Now, in development, that's not really a good idea because that doesn't really tell us what's wrong. What we have to do is we have to go and find this file. I'm going to look for it, PHP ini. It is in this folder. I am going to open it up with Visual Studio Code. And there's a whole bunch of configuration options. This is not really in a standard format. This means this is a PHP section. The semicolons mean comments. And there's a whole bunch of comments that tell you stuff. What we want to look for is what we want to do is we want to handle the error. We want to change how it handles errors. Here it's telling us what errors it's going to process. It's going to process all errors along with deprecated errors and strict errors. However, it's not going to display the errors. I'm going to change this display errors from off to on. I'm going to save it. And it's not able to save it. Try saving it to the desktop and copying it over. All right. Now, when we run this, we get a cryptic error. But a cryptic error is better than no error. So if we look at this, it tells us, first of all, that the first error that it found is in line 13. And it's telling us it encountered a equal sign when it wasn't expecting an equal sign. It was expecting a semicolon. Well, I have to admit that that's kind of hard to see how that error got generated from what we have. But it did at the very least point us to line 13. So if we look at it, the hope is that eventually we'll be able to recognize that, yes, we forgot our dollar signs. And we can save it and retry it, and it'll be fixed. What if I put in a $SS here? In other words, I put the wrong variable name. it actually doesn't give a, well, it does give us an error. It tells us an undefined variable, $SS. Well, that's actually a warning, not an error. But that actually is a fairly meaningful error. We can see that SS has not been defined, that S is our proper variable. What if we forget our curly braces at the end? It will tell us that there's an unclosed left curly brace on line 13. And it tells us the error is on line 23. In other words, it made it all the way to the end of the file and didn't find the matching curly brace. And of course, we can correct that. My point is that the errors sometimes are cryptic. They're not always 100% clear, but change your PHP ini file to allow for errors to display. And that gives you at least a fighting chance of being able to figure it out. And if you can't figure it out, well, that's part of what I'm here for, to help you figure it out and to help you interpret those error messages. All right. If you notice, inside this, I'm outputting HTML code. This is one sort of style of doing PHP. I have another version of the same example, PHP 2, or first 2 rather. Does the same thing, but it goes about it a totally different way. If we look at the view source to this one, notice that the source is a little more readable. In this, what I have is I interject PHP in the middle of HTML tags. In this example, I use PHP to output HTML tags. Here, I interject code as part of the HTML tag. So, I have a PHP block here that starts my for loop, a PHP block here that ends my loop. So in other words, this whole block, this TR, is going to get repeated 100 times. I calculate the value of S, and then I output the value of N and the value of S. I have the PHP block started, PHP block ended. This is very effective if you're working with a graphic designer that doesn't know PHP. They may mock a page up in HTML. All right. And all you have to do is go into their code and alter their HTML to interject PHP code where PHP code is required. So it's kind of a cool feature of PHP. It doesn't matter to me which one of these you use. You should be at least aware that there's 2 ways of doing it. That way, if you see an example online, it doesn't totally throw you. But style-wise, really doesn't make much of a difference to me which approach you take. Third example I want to go over today is processing data from a form. I have a form here that accepts a starting value and an ending value. So I'll put in a starting value of 3 and an ending value of 29. And when I click process, it shows me not from 1 to 100, but starting with 3 and going down to 29. Let's look at the form first of all, and we'll notice that there really is no PHP in the form. It's plain old HTML. Despite that, I made it a PHP page. Why would I do that? I would do that for consistency. And I would do that because there's some features of PHP, namely include files, that we'll study later on, that allow us to do some cool things as far as reusing HTML code. So if I'm doing a website and I'm doing it in PHP, I'm going to make all my pages PHP pages, even if they don't really contain any PHP. Because remember, a PHP page is simply an HTML document with some PHP interjected. Well, a plain old HTML document could also be a valid PHP. There's just no PHP injected in this case. Now notice that the method is get and the action is first3.php. When the submit button is pressed, this gets called and the values are passed on the query string. So if we look up here, we'll see that when we submit this form, it calls first3.php. That's the action of the form. And the values are passed on the query string. It says start equals 3, end equals 3, end equals 29, submit equals process. That's what it looks like. That's what gets called. This is from the action. This is from the fact that we said method equals get. It's going to take each form item, each name, and it's going to put it on the query string along with the respective value. From the server-side perspective, the server doesn't get informed where the data was from. In other words, the data could have been from a drop-down or a text box. When we send it to the server just gets the value of the data, not the type of control that the data was in. Now, let's look at code that processes this. Pretty much the same, except I get from the query string the value called start and the value called end. That corresponds to the name of these things in the form, start and end. And I put it in a variable start and end. I then run my loop, and instead of having hard-coded 1 to 100, it pulls a value from the query string value start and makes that the starting value, pulls the value for end and makes that the ending value. Can I break this? I bet I can. Can I break it this way? Nope. It just instantly I or n is greater than the ending value. So it just stops right off the bat. But I can break it this way. All right. Because obviously those values have to be a number. Now, how would I fix this? I could put validation on the client side to make sure that the user only enters a number. I could put validation on the server side to make sure that they only enter a number. I probably would actually do both because a person can turn off client-side validation through their browser. Your task for this week is number one, to get installed a web server on your machine that you're going to be using. It probably will, if you don't have a web server already, use XAMPP. How do you know if it works? Type localhost in the browser, copy my code into your web server root and try to run my examples and see if you get the results that I got in class. If you get that done this week, you're in good shape. If you want to go beyond that, study my examples, make sure you understand them, go through the tutorials that I have posted. I have a couple videos posted, and I have a couple of tutorials from the W3 School site, and study more about PHP syntax. If you're really feeling adventurous, try to start the next lab assignment. I think there's 2 weeks on this assignment, but no problem. You know, no worries if you get it and you want to take a head start on this. All right, this is all I had today. We will talk to you next week. Keep sending those questions in if you run into difficulties.